Today we're looking at notes X2, solve trig equations with multiple angles. This is because not just x will be on the inside. So like here, it's sine of 2x instead of sine of x. And you might see sine of 1/2 x or sine of 4x, etc., etc., etc. So here are your steps. Isolate x with the coefficient. So get x by itself. Of course, it'll have a coefficient, but get x by itself. Name where the value occurs on the unit circle. Create two formulas like we did in the previous notes X1. Then eliminate the coefficient and generate a list of answers using the new formulas. This is only if necessary. Now on today's assignment, it will be necessary because look at the instructions, the directions. Solve on the interval 0 to 2 pi. This means I don't want a formula for my final answer. Okay, I want a list of answers that fall between the interval 0 to 2 pi where I'm only including 0, not 2 pi. Okay, so if I didn't have this interval, if I said state all possible solutions, then of course my final answer could be a formula, but that's not the case on this. So on number 1, we have sine of 2x equals 0. So we need to take the arc sine on both sides. Okay, that would leave us with 2x equals arc sine of 0. Okay, take the arc sine on both sides. That's because we're isolating x with the coefficient. Then we need to name where that value occurs on the unit circle. Well, what angle has a y value of 0? So that would be here and here. Those two angles have a y value of 0. Okay, and so then create two formulas. So like before, remember we're dealing with sine, so it's going to be plus 2n pi. Plus 2n pi for these. So we've got 2x, excuse me, not x. Today we've got 2x. So it'd be 2x equals, in this case, 0 plus 2n pi. And in this case, 2x equals pi. The angle here is pi plus 2n pi. Okay, I've created my two formulas. Then you eliminate the coefficient. So I get rid of the 2 in front by dividing both sides by 2. I divide the left, I divide the right, I divide the left, I divide the right. Just make sure you share the love over here, okay? Divide both terms by 2. So on the left, of course, you'd have x equals, right? 0 divided by 2 is 0. 2n pi divided by 2 is just n pi. And then on this side, you would have x equals, and then pi divided by 2, which is pi over 2, plus 2n pi divided by 2 would be n pi. So what I want you to understand is to generate your list, we're going to use the formula. This isn't our final answer, but we're going to use the formula. And let's talk about it. So this is our starting point, correct? And then to get the next answer, you're going to add pi each time. So we're going to start at 0. So x equals 0, that's our start. And then we're going to add pi. So add pi to 0 and you get pi. Add pi to pi and you get 2 pi. Add pi to 2 pi, you get 3 pi. Add pi to 3 pi, you get 4 pi. I got carried away with myself and I crossed these out because, again, remember, our interval is from 0 to 2 pi and not even including 2 pi. So I've got to cross through that. That's not part of my answer. All I want is from 0 to 2 pi, not including 2 pi. So my answers are, for this part, 0 and pi. On this part, let's look at this carefully. So this is our starting angle, right? Pi over 2 is our starting angle after we eliminated the coefficient. And then from there, you're going to add pi every single time. If you plug in integer values, 1, 2, 3, etc., you're going to add pi every time to that. Now, I'm going to have to add pi to pi over 2. I want to get a common denominator. So in other words, instead of saying I'm adding pi, I'm going to say I'm adding 2 pi over 2 to make it easy. What I mean is, look at this. So pi over 2 is where you start. Then I'm going to add pi every time. But to make it easy to add, we're going to say I'm adding really 2 pi over 2 because that's the same as pi. So add 2 pi over 2 to this and you get 3 pi over 2. Add 2 pi over 2 to that and you get 5 pi over 2. Add add 2 pi over 2 to 5 pi over 2, you get 7 pi over 2. And then you get 9 pi over 2 if you keep adding 2 pi over 2. So of course I've eliminated these and crossed through these because this value right here is greater than 2 pi, and obviously then so are all those. We can only include answers from 0 to 2 pi, not inclusive on the 2 pi. So that's your final answer there. All right, so that was number 1. Let's look at another example. Example number 2. Cosine of 3x equals a half. Okay, so take the arc cosine of both sides, so 3x equals arc cosine of a half. Okay, draw your unit circle off to the side. That's what I'm going to do here. So we're talking positive a half, so positive x value. Remember, cosine is x. So the angle whose x value is a half. So that would be your over 3's, your twin, or not your twin, sorry, your flip-flop. Okay, so that's there. So then we're going to say, we're going to generate our two formulas. So 3x equals, because the 3x here, this is pi over 3. Since it's cosine and not tangent, tangent's the only weird one, it's 2n pi. And then 3x equals, this is 5 pi over 3, also plus 2n pi. So in this case, unlike the problem above, we could easily divide by 2. These were whole numbers, also whole numbers. This is a fraction, yuck. I'm not going to divide a fraction by 3. I'm not going to divide a fraction by anything because I don't want a fraction in a fraction. So I'm going to instead use my knowledge that I can multiply each sides by the reciprocal to get rid of the 3 here. So I'm going to multiply by 1/3 by the reciprocal. Just don't forget to distribute in. So obviously that would become just x equals, and then this will be, oops, pi over 9, 3 times 3 is 9, plus 2n pi over 3. And then similar on this one. So multiply by the reciprocal, 1/3. 1/3, so this would become x equals 5 pi over 9 when I distribute, plus 2n pi over 3. Okay, so remember, this is your start, and then this, let's convert it, you want to add 2 pi over 3 to the previous answer. In other words, you want to multiply both top and bottom, numerator and denominator, by 3 to get a common denominator. So this would be 6 pi over 9. And here, similar, this is your start, and then you're going to add 2 pi over 3, but again, you want to get a common denominator, so add 6 pi over 9. So let's start generating our list. So of course, first it starts with x equals pi over 9. That'll work. And then add 6 pi over 9 to that. So that would be 7 pi over 9 when you add 6 pi over 9 to that. And then if you add 6 pi over 9 to that, this would be 13 pi over 9. Have we hit 2 pi yet? Is this greater than or less than 2 pi? Okay, so 18 pi over 2 would be 2 pi, so we're still less than. Let's go one more. So add 6 pi over 9 to that, and it'd be 19 pi over 9. And what did we just say? 18 pi over 9 is 2 pi, and this is bigger than that, so we can't have that. So x equals, those are your 3 solutions on that problem. And then on this problem, x equals 5 pi over 9. Okay, add 6 pi over 9, and that would give you 11 pi over 9. We're still good. We're still in the clear. Add 6 pi. That would be 17 pi over 9, and you know 18 pi over 9 is 2 pi, so we definitely don't want to go any further than that because the next answer would be greater than 2 pi. So you're done there. Okay, so let's move on to number 3. Okay, so tangent of x over 2 equals -1. So arctan on both sides, so x over 2 equals arctan -1. So draw our unit circle. Okay, so tangent values are negative here, quadrant 2, excuse me, quadrant 4. Okay, so those are our twins. And then, so you have x over 2 equals, okay, x over 2 equals 3 pi over 4 plus n pi. Remember, we're dealing with tangent, so n pi. And then x over 2 equals, this is 7 pi over 4 plus n pi. Okay, so then we want to get x by itself, so multiply by 2, multiply by 2. So this is going to be x equals, of course, when you multiply by 2 here, what's going to happen is you would have 6 pi over 4, because this is like 2 over 1, right? So 6 pi over 4, which would simplify to 3 pi over 2 plus 2n pi. Okay, and then on this we would have multiply by 2, multiply by 2, which is like multiplying by 2 over 1. Same here if you want to see it that way there. Okay, so x equals, this is going to simplify to 7 pi over 2 plus 2n pi. Okay, again, this is your start. And you're going to add 2 pi every time. But to get that common denominator, that's the same as adding 4 pi over 2 every single time. Here, this is your start. And you're going to add 2 pi every time, which is equal to get a common denominator, 4 pi. So adding 4 pi over 2 every time. So here we have x equals 3 pi over 2, 3 pi over 2 is our start. All right, and then you're going to add 4 pi over 2 to that. Well, y'all, that's right there, that's 2 pi. You don't even need to think about that. If you're going to add 2 pi to anything, obviously, other than 0, it's going to be greater than 2 pi. So that's our end list here. That's our end list here. And then here, x equals 7 pi over 2. That's our start. And of course, again, if you're going to add 2 pi to that, of course it's going to be bigger. But wait, all right, this list is part of the other list because it's tangent. All right, so this, cross this out, this list repeats, okay, part of the other list because it's tangent. And what I mean by that is, what if I would have added the 4 pi over 2 to this right here? This would have been 7 pi over 2, which is exactly what that is. Okay, this list repeats, and we don't need this second equation here because remember, when we talked about formulas with the tangent before, we said we only talk about the top half because of the whole plus n pi instead of the plus 2n pi. So this is repetitive, plus not only is it repetitive, but it's greater than 2 pi. So therefore, you didn't even need this whole list. Okay, so then that's with tangent. Remember, that's only with tangent. Number 4, last one, secant of x over 2 equals negative square root 2. So then, in this case, your first step is to reciprocate both sides. So cosine of x over 2 equals, reciprocate negative square root 2 over 1, which would become negative 1 over square root 2. And then, of course, you're going to rationalize. So you're going to have cosine x over 2 equals negative square root 2 over 2. I want to pause, take a minute to write a note to you, because some of you might have noticed this, others of you didn't. Reciprocate both sides of equals, right? So we reciprocated both sides of equal sign, but notice the angle didn't change. So we reciprocated this, but that angle didn't change. Okay, the angle stayed the same. So I just want you to be aware of that. If you didn't think about it, that's good, I guess. But if you did, now you know. Okay, so there's that. And then, of course, arc cosine left and right. So x over 2 equals arc cos negative square root 2 over 2. And then the angle whose x value is negative x value, hint, hint, square root 2 over 2, that's your twins. So x over 2 equals, this is 3 pi over 4, so 3 pi over 4, since we're talking cosine, it's 2n pi. And then x over 2 equals, that's 5 pi over 4 plus 2n pi. Of course, we need to multiply by 2, or 2 over 1 on each side. Okay, so here we have x equals, this is going to simplify to 3 pi over 2 plus 4n pi. And then x equals, this is going to simplify 5 pi over 2 plus 4n pi. Look at how this works out. So remember, this is your start. And this means add 4 pi. Hello, we don't even want to do that because that's already way too big. Same, this is your start. And then to add 4 pi, that would make our answers out of our interval. So this is going to be x equals 3 pi over 2. We're not going to add any more to that because we know that would put us out of our interval. And then here, this is x equals 5 pi over 2. But y'all, why am I boxing it? That's too big. That is already out of our interval.